right, ladies and gentlemen, welcome to another edition of Science with Mama J. Today we're going to be looking at activity 7. We're going to be working on identifying solids. So we have all the solids that were in our unknown substance, and we're going to be conducting some tests to identify electrical conductivity, density relative to water, density relative to ethanol, and reactions with copper chloride. So the first thing I'm going to do, of course, is put on my protective equipment, okay, because even though the solids themselves don't appear to be hazardous, I'm going to be working with some lab-grade denatured alcohol as well as some copper chloride, and we don't want to get that in our eyes. So, gloves as well, because I don't want to expose my skin to any of that either. So let's go ahead and take out all of our solids. Now the metals are pretty clean. The plastics might require a little bit of cleaning, only because, especially the red one, it is a tube. So I'm going to go ahead and wipe off the plastics as well as I could. Well, they appear to be plastic. We haven't identified them for sure yet. Dip it in a little bit of water, clean it off. And take the red one and do the same. Okay. In this case, I'm going to try to get the inside clean as well. So, first test is the electrical conductivity test. Okay? So, I'm going to start with the large metal cylinder. Okay? So, the large, long metal cylinder. Using this with gloves is a little tricky. And we try to do it in such a way that you can see what happened. The light turned on, so the large metal cylinder does conduct electricity. The next one we're going to look at is the short metal cylinder. And again, the light turns on, so that one does conduct electricity. So now we're going to go ahead and look at the plastic cylinder. Now this one's a little bit easier because I can actually grip and hold it. So this definitely does not have any metal in it at all. It does not conduct any electricity. And the fourth is this black plastic looking thing. And it does not conduct any electricity. So the two metal pieces do, the two plastic looking pieces do not. So the next test is density relative to water. Now we have density relative to water and density relative to ethanol. So here is water. I'm going to put 5 milliliters of water in this graduated cylinder. Five milliliters of water, and that's going to go in here. And I'm going to keep my water tube here so that I know it goes with that graduated cylinder, because we do not want to cross-contaminate. That will impact our results. And I'm taking my denatured alcohol and I'm pouring it in this tube, in this graduated cylinder, and I need 5 milliliters of that as well. And I'm going to put that in this vial. So we're going to start with our 2 metallic objects. I'm going to start with the first one, and I'm going to place it in water. And it definitely sinks in water. You can cap it and shake it up a bit, but it definitely sinks in water. So I'm going to pour the water into a second vial so as not to waste it. And this is a neat trick to get the water out and not have to constantly remeasure, and at the same time get your sample out. So now we want to dry the sample before it goes in, because again, we do not want to cross-contaminate. So we're going to take this and we're going to put it in ethanol. So this particular substance, get a dry top, sinks in ethanol as well. So it sinks in water and it sinks in ethanol. So again, pour the ethanol into a second vial so that we can reuse it. And grab our sample and place it to the side. We're going to repeat the step, first with water, with the second smaller metallic cylinder. And I don't think we need to cap it to realize it sank straight to the bottom. So we'll drain our water and then take our sample okay, and that one we want to make sure we dry completely as well. And then we're going to go ahead and place it in the ethanol. Woo, splash. We're going to have to add some ethanol to this. And it went straight to the bottom. So what I'm going to do is I'm actually going to pour the ethanol in here so that I can make sure I have a full 5 milliliters, because we did lose some ethanol that sank like a stone. And we'll take our sample out. So I got to get us back to 5 milliliters. And of course, pour it into a fresh vial. Now, since I did get the table a little bit wet, the wise thing to do is to clean it off. Okay. So the next one is the large red cylinder, or well, compared to the black piece, it's large. And we're going to put it in the water first. Okay. And we're going to cap it. Shake it up. And although it floats, the top portion stays below the surface of the water. So it does float, it just sits right below the surface of the water. Hopefully you can see that. I'll go ahead and pour this water in. Put our sample down. Dry it off. Then we're going to take our red tube and place it in the ethanol. Shake it up, and it sinks completely in the ethanol. So it floats in the water, but it sinks in the ethanol. So its density relative to the water is less than the water, whereas the two metal pieces, they were both greater than water, and its density relative to the ethanol is, its density is less than the water for the red tube, greater than the water for the two metal pieces, but the density relative to the ethanol for the red tube is less. Okay? Oh no, the density relative to ethanol is still greater for the red tube. It's less for the water, but greater for the red tube. I think that's what I said. That is correct. The metal pieces, density was greater regardless of the substance. Looking at the black piece now, the black square. Let's take a look in water. Oh, it would help if I could get the top on. There we go. No matter how much I shake it up, it floats. So the density relative to water, the black square piece is less. Now, of course, getting the forceps in there is tough, so I'm going to pour the water out to make it easier to get that out. I don't really need it in a new vial, but just so that I can get access to it. And then the last test is the black piece in ethanol. And it sank right to the bottom. So the density relative to ethanol, the density of the black piece is greater. And I'll go ahead and pour the ethanol out so that I could get my sample out. So now, the last thing we're going to look at is a reaction to copper chloride. So I'm going to make sure our wells are clean here and place the solid being tested in the CPUP tray, and then we're going to place 5 drops of copper chloride on the solid. So I'm going to place my metal pieces standing up so that we can just place it on a flat surface. And plastics, well, the red and the black, they appear to be plastic. See if I can get this straighter, because I want the copper chloride to sit on it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so not sure if you can see this, but the two metal pieces definitely show a reaction. Okay, this one is foaming up. The copper chloride is a very pretty blue-green, but as you can see on the second piece here, it looks very dark. So both of the metals do have a reaction, And the red piece, there is no reaction. And the black piece, there is no reaction. So I'm going to take the metal piece out to see what it looks like. And I'm going to go ahead and I'm going to rinse it off in some water. I'm going to take my water here. And I'm going to rinse it off. And it definitely produced a reaction, because this now is what my metal piece looks like from this pretty shiny silver. For the second one, I'm going to do the same thing. And although the reaction wasn't as intense, you can see there is a discoloration on the metal. There's a discoloration on the surface and on the side. So both of the metals did have a reaction. The first metal had a very dark, big reaction where it turned very dark. The surface, it's hard to tell, but the surface is actually corroded. And the other one, the surface has dulled and has a bit of a color change. The red cylinder, there was no change to the cylinder at all. It looks exactly the same. And the black cylinder, or the black square, excuse me, had no change at all. In fact, looking at my wastewater, there is a brown substance sitting in the water that came off of the very first one. So I hope that helps. Those are the results. We will discuss in class tomorrow how these results impact our understanding of what the substances are. And I look forward to seeing you tomorrow. Have a wonderful night. Bye.